Okay, mock paper number 1. Let's go. So question number 1, we are subtracting fractions. First thing we notice is that these are mixed numbers. So we've got numbers at the front, so we need to get rid of those to start with. So we do 2 times 5 is 10, add on the 3 gives us 30 out of 5. And the second one, 1 times 6 is 6, add on the 5 is 11, so we get 11 over 6. Next thing we need to do is get our denominators the same, so that's the number on the bottom. 5 and 6 both go to 30, because if we multiply them together, we get 30. So we're going to have something over 30, take away something over 30 to get our answer. So this first fraction, we've times that by 6 to get the 30, so we need to do 13 times by 6. We know that 10 times 6 is 60, 3 times 6 is 18, adding those together gives us 78, and then 5 times 11 is 55. Now we can do our subtraction. We know our denominator is going to be 30, and the numerators, taking those away, is going to give us 23 for our answer. Okay, question 2, we are looking at a straight line graph. We've got the cost of a call in X number of minutes, and the cost on our y-axis. We need to give an interpretation of the y-intercept, so over here, and then the gradient. So calculate our gradient, doing our rise divided by our run. Starting off with the y-intercept, that is going to be the cost at the start of the call, because that is when we are at 0 minutes. And we can see that that is 50 pence. So there we go. And then we want the gradient. So we can see we're going across 2 and we're going up by 3. So our gradient, doing our change in y divided by our change in x. 3 divided by 2 is 1.5 or £1.50. And that is the cost per minute. So it costs £1.50 per minute. Then using these two values to get our equation of the line, the gradient is our m value, so that's 1.5, and the c value is our start or our y-intercept, so 0.5. Okay, question 3, we need to find the area of this shape. Fairly complex shape, so let's cut it down into things that we can work out. So first thing, we can cut it into this triangle at the top and a rectangle at the bottom, and then find the area of these two things. Find the area of the rectangle, that is nice and straightforward. So the area of B to E to D to C is just going to be 4 times 8, which is 32. The area of the triangle, we've got the base, because we can see that that is 8, but we haven't got the height, so we need to work that out. We can see now we've got a right angle triangle here, and if we look at that triangle, we've got that that is 4, we've got the hypotenuse is 5, and it's right angled here. So right angle triangle, 2 sides, we can use Pythagoras' theorem to find the height. 5 is our hypotenuse, so to find the length from A to this point here, let's call it M. A to M is going to be 5 squared, take away 4 squared, but that will give us AM squared, so we need to square root that to get the height here. This is one of our standard Pythagorean triples. If we work it through, we can see that's 25, take away 16, which equals 9. Square root of 9 is 3. So the height of this triangle is 3. And then we can use that to work out the area of the triangle. So the area of AEB, that triangle, is going to be the base, 8 times the height, which is now 3, divided by 2. 8 times 3 is 24, divided by 2 is 12. And now we've got the two parts of this shape to find the total area, which is going to be 32 plus 12, which equals 44 centimeters squared, units already given. Question number 4, we are looking at this train journey from Manchester to London. First thing we're going to look at is the times. So that is 8:35 to 11:05. It would take us 1 hour to get to 9:35, 2 hours at 10:35, and then an extra 30 minutes up to 11:05. So that is 2 hours, 30 minutes, or 2.5 hours, keeping it all in hours. Next thing we've got is our speed. So that is 110 miles per hour. So we're going to be looking at using speed equals distance over time to work out the distance. So the distance is our speed times our time. In this case, that's the 110 times by the time of 2.5. 2 times 110 is 220. 0.5 times 110 is 55. Adding those together is going to give us 2.5 times, so 275 miles. And that is the distance for Tarek, so let's call it DT. Next up, we've got Jill doing the same journey, but she's been diverted, so she's got to travel slightly further. So the distance for Jill, let's call it DG, is going to be the 275 plus on the extra 37 miles. So adding those together is going to give us 312 miles. Next, we need to know the average speed between the two. So she left at the same time, but her journey has taken 3 hours. So the time for Jill is 3 hours. And that was the time for Tarek at the top. So the speed for Jill is going to be the distance, 312 divided by the time, which is 3. 300 divided by 3 is 100. 12 divided by 3 is 4. So that's going to be 104 miles per hour for Jill. That's not what we're asked to work out though. We're asked to work out the difference between the two average speeds. So we just have to do 110, take away 104 to get 6 miles per hour as the difference. Okay, so we're now tiling the wall. And we've got these tiles that are 60 centimeters by 30 centimeters. We're trying to cover the area of 6 meters times 1.8 meters. First thing we're going to work out is the total number of tiles needed to cover that. So what we can look at is how many we would fit along the length here, and then how many we can fit along the width as well. For the length, we're going to use that 6 meters, convert it to centimeters though, so 600 centimeters, and divide it by the 60 we've got for the length of each tile. So that is going to give us 10 tiles along the length. For the height, we're going to do the same thing. So converting the 1.8 meters to centimeters, 180, and divide that by the height of each of the tiles. So divided by 30. 18 divided by 3 is 6, and the 2 zeros are going to cancel as well. So we get 6 there, and that is the tiles along the height. So in total, we're going to have 10 times 6 equals 60 tiles covering that wall. We have got 3/5 of those tiles are going to be white. So we're going to do 60 times by 3/5. So we can do 60 divided by 5 is 12, times by 3 is 36. So we've got 36 white tiles. And the remainder of the tiles are going to be either green or blue. So 60 take away 36 is 24. So we've got 24 tiles that are green or blue. And we can see that the ratio of those tiles is 1 to 3. So taking these two parts, 1 plus 3 is 4, which gives us 4 parts in total. So next thing we can do is 24 divided by 4, so that's the total number of parts from our ratio, which is 6, and then times this 6 by 1 and 3, the green tiles and blue tiles respectively. So 6 times 1 is obviously 6, and then 6 times 3 is 18. So that gives us the number for each tile. As a quick check, if we add this up, we should get back to our 60, which is our number of tiles that we needed. So 36 add 6 is 42, add on the 18 gives us our 60, so that's good. Next we're told that he should leave gaps between the tiles. So if he leaves gaps, what would this do to the number of tiles? Well, it means there's going to be spaces between them, so along the length and along the height, we're not going to need as many tiles. We might not need as many tiles because we might need to cut them. So he may need fewer tiles. Cool. Okay, here we have got a distance time graph, and we've got a bit of information about the journey here. So let's start filling in the information we've got. So we've got that Ria leaves at 1 o'clock, 1300 hours. Then drive for 30 minutes at a constant rate of 40 miles per hour and takes a break. So that is our break here, and that's taken 30 minutes. So this is going to be 1:30, and then moving on, this is going to be 2 o'clock, 2:30, 3 o'clock, 3:30, and so on. 4 o'clock, 4:30 is going to be here, and then 5 o'clock at the end, so 1700. Okay, we've also got the speed here. So again, using speed, distance over time, we can work out the distance that it took before she had a break. So our distance there is going to be our speed, which was 40, times by the time, that is 0.5 for half an hour. 40 times 0.5 then is 20, we're halving that. So the distance up to here is 20, so each of these is going to be 5. So 2 is 10, that's 30, 40 up to there. So we can see that at 3 o'clock when she arrived at the hospital, she was 40 miles from home. Okay, she was then at the hospital for 30 minutes. So we can put that in on our graph. That's going to be a straight line up until 3:30, and then drove home at a constant speed of 32 miles an hour. So we're going to work out the time there. So the time using our formula is going to be distance over speed. The distance we worked out is 40 divided by 32. Okay, so if we simplify down this fraction, we might be able to work out what it is exactly. So we can divide both of these by 8 to start with, which is 5 over 4. And then 5 over 4, well, that is 1 and 1/4, or 1.25. So it takes her 1 1/4 hours to drive home, or in hours and minutes, that is going to be 1 hour and 15 minutes. So putting that in on our graph, 1 hour would take us to 4:30. Extra 15 minutes there is going to be 3:45. We just grab our ruler. We can put that in nice and clearly onto our graph. So lining that up there, just showing clearly what we've done. Okay, so there we can see she arrives back at 16:45, so not before 1630 as we are asked to show. Right, for question 7 we are getting an estimate for the value of this. For a reasonable estimate of these sorts of things, we're expected to round each number to one significant figure and then work it out from there. So 43.2, that 3 is going to leave the 4 as it is, so it's going to round to 40. 99.05, that 9 is rounding this 9 up, so that's going to round up to 100. And the 0.193, that 9 is rounding the 1 up, so that's going to be 0.2. So we can start to work this out now. So the 40 we're going to leave for a second. Square of 100 is 10, and 0.2 we can leave. And then we've got 40 times 10 is 400 divided by 0.2. Now here we could try and work out divided by 0.2, or we could treat this as an equivalent fraction and try and get it up so that this bit on the bottom, our denominator, is 1, and that will give us our answer. So to get 0.2 up to 1, we're going to times that by 5. So if we do the top and bottom times by 5, that will give us our answer. 400 times by 5 is 2000. 0.2 times by 5 is 1, so it's 2000 over 1, which is just 2000. Question 8, we are looking at two translations, so shape A to shape B, and then shape B to shape C, and we want the single transformation from A to C. So we're going to do a translation followed by another translation. To work out what the vector is going to be, we can do the first one, add on the second one, and work that out. So 4 plus minus 3 is 1, and then minus 7 plus minus 2 is minus 9. So that is the vector of our translation. We are after the transformation, so we need to state that it is a translation with vector 1, negative 9. Okay, a good way to think through this problem is to think about how long it would take one machine if it was working to make all of these bottles. So if 8 machines take 5 days, then one machine would take 8 times 5 days, which would be 40 days. So let's call that a machine day, or MD, for how long it would take to make this. For the first 2 days, we've got only 4 machines working. So what they can produce in that 2 days is 2 times 4, which will be working for 8 machine days. So the remaining machine days we need to cover to get it up to this 40 is 40, take away the 8, which is 32 machine days. And then we've got all 8 machines working for the remaining days. So what we can do is 32 divided by the 8 machines we've got working, which is going to give us 4 days. So after the first 2 days, when we have only the 4 machines working, once we've got all 8 machines working, it's going to take 4 more days. So 2 days plus the 4 days gives us 6 days in total. Okay, quite a harsh question for only 1 mark here. We need a good understanding of our index rules to be able to work this out. So we've got negatives and we've got fractions. Doesn't matter what order you work these out in. I like to get rid of the negatives to start with. So a negative on our index does a reciprocal. That means we're going to do 1 over. So we get 1 over 64 to the power of 2/3. Now we've got to look at what this fraction does. So a fractional indice does a root, and the root comes from the bottom part of the fraction. So that is going to give us a cube root. So we've still got 1 over, and we're going to look at the cube root of 64. And then the remaining part, that 2 on top, stays as our power of whatever we get there. So the cube root of 64, that is 4. So we get 1 over 4 squared. 4 squared is 16, so our final answer is going to be 1 over 16. Question 11, we've got to match these cumulative frequency graphs to our box plots. On our box plot, the information we can show here is the minimum and maximum value, the median, and then the upper and lower quartiles. We can also get those fairly quickly from our cumulative frequency graphs as well. So on each of these, the minimum and maximum is the same. That's our start and our end point on our cumulative frequency. So those values aren't going to help us. It's going to be all on the medians and the quartiles. To get the median, we're going to go halfway up on our cumulative frequency, go across to our line. So on this one, that's going to be there, and then go down. So for this one here, the median is exactly halfway on the height, on the range we've got. Similarly over here, that one is again halfway. So that means that A and D have to be either W or Y, some way around there. So to work out which is which, we have to look at the quartiles as well. And we get the quartiles in a similar sort of way by looking at the cumulative frequency. So the lower quartile is the lower quarter, and that is there, and the upper quartile there, and then going down to the height. Do the same thing over here to get that value there and the lower one there. So we can see from there that for A, there is a much smaller interquartile range. The two quartiles are much closer together. So that is going to match to Y. So A goes to Y. And then on graph D, much bigger interquartile range. So that is going to be W for D. For the other two, we can just compare the medians here, so that middle value. So on C, we've got quite a high median, and on B, a much lower median. So relating those, this one has the lower median for X, so that's going to be B. And then C, the remaining one, has to match to Z. Right, this one we are trying to find the percentage reduction of this jacket. First thing we need to do is work out how much it has decreased by in the cost. So we're going to do 52 take away the £41.60, which is the new price. 0 take away 0 is 0, 0 take away 6 we can't do, so we're going to borrow 1 from the 2 there. So we've got 10 take away 6 is 4, 1 take away 1 is 0, 5 take away 4 is 1. So we've got £10.40 is the price it has gone down by. We want to work out what this is out of the £52 we started originally to get the percentage. So that is £10.40 out of 52. To get this as a percentage, we are going to times by 100. So working this out, that's going to be 1040 over 52. And then we can simplify this down to get our percentage. So we can half both of these, so that's going to be 520 out of 26. We can half those again, so half of 52 is going to be 260 over 13. And then 13 goes into 26 twice, with the extra 0 there. It's going to give us 20% reduction. Okay, we are proving that the difference between any two different odd numbers is an even number. So our odd numbers take the form 2n minus 1, and we have to look at different odd numbers. So that means we have to look at 2n minus 1 and 2m minus 1 for it to be a different number. We're doing the difference of these two things, so we're going to do 2n minus 1 take away 2m minus 1. So if we work this out, it's going to be 2m minus 1 minus and then minus and a minus there is going to give us plus 1. So that gives us 2n minus 1 here, plus 1 is going to cancel out. So we get minus 2n minus 2m. Now we've got a 2 with both of these, so we can factorize that out, which is going to give us 2 brackets n minus m. And this has to be even because we've got a factor of 2. So even as we have a factor of 2. Okay, this one we are writing a recurring decimal as a fraction. Good way to start with this is to write out a few more digits of our decimal. So we've got the 2 and the 4 recurring, so those are going to repeat over and over and then carry on. Now to get this as a fraction, we need to somehow cancel out some of these things. So what we can do is if we times it by 10, we can shift up the number by a factor of 10 and hopefully cancel out some of these numbers. 10x is not going to help us in this case because none of these match up. So what we can do is go to 100x and see if that helps. That's going to move it up again. Now here, with the 100x and the x, they do match up some of these. So if we were to take these away, all of these are going to cancel out. We've still got these ones here. So what I'm going to do is go up to 1000x instead. So that'll give us 624.2424. Now if we compare some of these, the 1000x and the 10x have the same numbers after the decimal point. So if we do 1000x, take away 10x, what we can do is this number take away this number. So it's going to be 624.242424, take away 6.242424, but all of these decimal bits are going to cancel out. So all we're left with is 624 take away 6. Now this is just an equation which we can work out. So 1000x take away 10x is 990x. And then 624 take away 6 is 618. So the fraction, if we divide by 990, it's going to be 618 over 990. So that is our answer as a fraction. We need it as a fraction in its simplest form though. So we've got to cancel this down. What you want to do here is divide by the biggest or most practical number to do so. We could divide by 2, but actually it's going to be easier to divide by 3 to start with, because 3 goes into these nice and easily. So 618 divided by 3 is going to give us 206. 990 divided by 3 is 330. And now if we divide this by 2, it's just a little bit easier. It's going to give us 103 over 165. Okay, for question 15, there's a variety of number of different ways you can solve this problem. What we're trying to find is the depth of the bottle, so that length there. Different ways we can do this is we could complete the square on this, because that will give us the value of the minimum point of this curve. We could differentiate if you've looked at a bit of further maths, because that will tell us where the gradient is 0, so you can look at that. Or we can look at these values here, and because it's a quadratic, we could then half that to find the middle value. So that's what we're going to look at for this method. So those two values are where this has a solution. So that means that y is equal to 0. So we can set x over 10 minus 3x equal to 0. And then we want to solve this. So we can start by getting rid of that 10, which will give us x squared. Times it by 10 means we have to do this 1 times by 10, 30x. And then 0 times 10 is still 0. Then if we factorize this, it will give us our two solutions. And we can take out x, which will mean we get x brackets x minus 30. So one solution is when x equals 0, and we can see that because that is where it touches there, and the other one is when x equals 30. So it's over here, x equals 30. Halfway between these two things is going to be x equals 15. So if we use that value as our x value, we can work out what y is and get the depth of our bowl. So we're going to sub in x equals 15 to find y. So 15 squared over 10 minus 3 times 15. 15 squared is 225 over 10. 3 times 15 is 45. So that's 22.5 take away 45, which is minus 22.5. The depth of the bowl is going to be a positive number, so it's just going to be this, but positive 22.5. As previously done, you could do this problem by finding the two roots and then finding the midpoint, or you could do it by completing the square. So let's look at that as well. So to complete the square on this, we first need to get the coefficient of our x there to be 1. So that means we need to factorize out the 10th we have there, which will give us x squared. If we're factorizing out a 10th, we need to take it out of the minus 3x as well. So if we're taking out a 10th of that, that will give us 30x. We can now complete the square on this part, which will give us y equals, complete the square, we half the coefficient on the x. That goes inside our bracket, and then we take that away and square it. So 15 squared is 225, taking that away gives us 225 there. We can now expand this back out again, which is going to give us y equals minus 1/10 x minus 15 squared, and then 1/10 of the 225 as well, so 22.5. And we don't need the bracket on the end. So what this tells us is the value of that minimum point there is when x equals 15 from within the bracket, and then the y value, if that end value there, is minus 22.5. So that length there, or the depth of the bowl, is going to be 22.5. Okay, evaluating Charlie's method here, we are looking for whether he's made any mistakes. So we can see that from B to C, which is what he's trying to work out, we are going from B to A and then A to C, which is minus B plus A, which is fine. So that first part of his work is correct. We're then looking at from B to M, so this part here in relation to B to C. And what we're told is that there is a ratio between those two lengths, and it's 2 to 1. We can see that Charlie has said that it's halfway, but that's not going to be the case because this journey we've got 1 to 2 there. So actually B to M is half the length of M to C, not half of B to C. So he has halved it rather than taking the ratio. Okay, for Martin's expansion here, we want to explain why Martin cannot be correct here. It is worth only 1 mark, so we don't need to expand all of this out. That's not what they're asking us to do. There's going to be something slightly simpler to spot here. The key numbers to look at here are often the first one and the last one, because those are quite straightforward to work out. We get the first one by multiplying the first 3 terms together. So 2x times 2x times 3x, 2 times 2 times 3 is 12. X times x times x is x cubed. So that is correct. The last number we get by multiplying the last three numbers here. So we get plus 1 times minus 3 times plus 2, which equals minus 6. Martin has said that it equals plus 6, so we can see that that is wrong. So we can say the n term should be minus 6. Okay, a number of different ways we can do this one, applying lots of different circle theorems. First thing to mark down is the angle that we are given. So that is angle BDC. There's our BDC. So we are given that this angle equals 57 degrees. So the first thing that I notice with this is that we've got the tangent and we've got a triangle. So we can use the alternate segment theorem to find another angle. And what that says is the angle here on the alternate segment in the triangle over here is going to be the same value. So that is 57 there. So let's write down what we've got there. We've got angle BAD equals 57 degrees by the alternate segment theorem. That does say theorem. Okay, next we can look at what else we can work out up here. So we've got the midpoint of our circle, so that means from O to A is the radius, and from O to B is also the radius. So these two lengths are the same. Those two lengths are the same, that means these two angles are the same, so that has to be 57 degrees as well. So let's write down that. So angle OBA equals 57 degrees because the triangle ABO is isosceles as AO and BO are radii. Okay, we're pretty much there now because we just need to work out angle AOB, so that is this angle here. So by angles in a triangle, we can do 180 minus the two angles we've just worked out, and work that out. So if we're doing 180 minus adding those two together gives us 114. 180 minus 114 is 66. By angles in a triangle, add up to 180. Making sure we give a clear reason for each of our steps. Okay, here we're looking at the sequence in this spiral. Having it as a spiral is a little confusing to see what's happening, so I'm just going to write out the sequence again. So we've got 1.5, 3, 5.5, 9, and then 13.5. So with a sequence, we're always going to look at what is happening from term to term to start with. So here we can see we're adding on 1.5. Next, we are adding 2. Then from 5.5 up to 9, we are adding, that's not right, that's 2.5 there, 3.5. And then from 9 up to 13.5, that is at 4.5. So the differences are changing here. So we're going to look at the differences of the differences. So 1.5 up to 2.5 is plus 1 there as well, and plus 1. So the second differences are the same. So that tells us it's a quadratic sequence. Quadratic sequence is with n squared. A normal quadratic sequence usually has a second difference of 2 here. we've got half of that, so we're actually going to have half n squared as part of our sequence. Now we've got to work out the rest that goes with our nth term. We know that it's going to have a half n squared because of these differences here. So what I'm going to do is write down what a half n squared looks like. So when n is 1, we're going to get 1 squared, and half of that is 0.5. When n is 2, 2 squared is 4, divided by 2 is 2. When it's 3, 3 squared is 9, divided by 2 is 4.5. When it's 4, we get 16 divided by 2, which is 8. And when it's 5, we get 25 divided by 2, which is 12.5. Now what we're going to do is compare what we do to get from 1.5 to 0.5, 3 down to 2, 5.5 down to 4.5, 9 down to 8, and 13.5 down to 12.5. And we can see that we're taking away 1 for each of these values. So what we can say is to get from this sequence back to this sequence, we need to add on 1. Good way to do this is to just do this one, take away this one for each of these values, and I will end up as +1 for each. Okay, to prove that these two triangles are similar, so that is the triangle ABD, ADB, and CBA, CBA. To prove those are similar, we need to show that all 3 of the angles inside the triangles are the same. So firstly, we can say that the angle DAB equals the angle ACB equals 90 degrees as given. So we've got that those two are equal already. Next, what we can do is if we label some of these angles, we can start to work out what some of the others are. So let's call this one X and start from there. So if angle ADC equals X, then we can say that the angle up here, so DBA, equals 180 minus the 90 here minus X. So 180 minus 90 is 90 equals, so that is going to be 90 minus X. And that is as angles in a triangle add up to 180. Okay, we also want to work out a couple of these angles as well. So we've just got that this one is 90 minus X. Let's work out what this one is here. So that angle there from this triangle, as that angle is right angled, so we can say that DCA equals 90. That is because the angles here are in a straight line, and we've got that that one is 90. Once we've got that, we can then use angles in a triangle to find angle DAC. So angle DAC, for the same reason as before, it's going to equal 90 minus X. And that is as, again, angles in a triangle add to 180. Next up, we want to work out the angle, the remaining angle here. So we got that this one is 90 minus X. That one there, we can again use the information we've got here. So we've got that that whole angle is 90, and then we've got this one here is 90 minus X. So angle BAC is going to equal the 90 we've got minus 90 minus X. 90 minus 90 is 0. minus x is going to give us x. Okay, so what we've got is the large triangle here has angles x, 90 minus x, and 90. And then this one here also has angles x, 90 minus x, and 90. So as both triangles have the same angles, they are similar. Okay, simultaneous equations here. So because we've got some squares here, we're going to have to do it by substitution. So to do it by substitution, we want to get this second equation into a form and we can sub it into the first one. So what we can do there is we can make x the subject. We can say x equals, it's going to be 2y minus 3. So we're adding on the 2y to this side. What we can then do is if we label that one 1 and this bottom one 2, we can sub equation 2 into 1. So that means wherever we've got an x here, we're going to replace it with 2y minus 3. So we get 2y minus 3 all squared plus the y squared from the equation equals 18. So now we've got an equation in terms of just y. So we need to expand this out and then see if we can work out what y is. So expanding this out, it'll be useful to write it as a double bracket and then expand it using one of our methods there. So we've got 2y times 2y is 4y squared, and then we can do minus 3 times minus 3 is plus 9. 2y times minus 3 is minus 6y, and then minus 3 times 2y is again minus 6y. Plus on the y squared equals 18. And then simplifying this, so we've got 4y squared plus y squared is 5y squared. Minus 6y minus another 6y is minus 12y plus 9 equals 18. This is a quadratic now, so let's make it equal to 0. So we're going to take away the 18 there, minus 9 equals 0. Now what we've got to do is factorize this so we can find out what y is. So because we've got a 5y squared here, we're expecting one of our brackets to have 5y and the other one just y. Then we can look at the minus 9 and think about what multiplies to make minus 9 there. So it's either going to be 3 and 3 with positives and negatives, or 9 and 1. Those are the only factors we've got for this. So let's just try out and see what happens with each of those. I'm guessing that it's going to be 3. It might not be. Let's have a look. So if we put 3 here, we can do 5 times 3 is 15. And then we've got another 3 here. We tick that off. That would give us minus 12. So that looks good. So we need to get minus 15. It's going to be that one. Add on 3 will give us minus 12. Then we can solve each of these. So this one is going to give us 5y plus 3 equals 0, which means 5y equals minus 3, or y equals minus 3 over 5. This one here, a little bit more straightforward. Y minus 3 equals 0, so y equals 3. So we've got our two y values for this. Now we need to go back to the equations and then sub in these values to get our x values. So we can sub them into equation 2 here and work out our two x values. So sub into 2. Subbing this into equation 2, we're going to do 2 times minus 3 over 5 minus 3. So let's write that down. So it's 2 lots of minus 3 over 5 minus 3 to get our x value. So x equals there minus 6 over 5 minus that. Whatever that is. So this is minus 15 over 5. Minus 6 minus 15 is minus 21 over 5. Subbing in the 3 a little bit easier. So 2 times 3 is 6 minus 3 is 3. So the two solutions we get is x equals 3, y equals 3, or x equals minus 21 over 5, and then minus 3 over 5. And if we had time, we could sub both of these back into our equation 1 to check that they do equal 18. Right, question 21. We are rationalizing the denominator of this fraction. So that means getting rid of the square root here. The way we do that is by multiplying by another fraction that is going to cancel out this third. And the one we pick is similar to this, except we change it to a minus there. And we'll see what happens when we multiply this out. So if we multiply by this, we can multiply the tops together. That is expanding the double brackets we have here. So we can do 3 times 5 is 15. Root 2 times minus root 8 is going to be minus root 16. Then we've got 3 times minus root 8 is minus 3 root 8. And then root 2 times 5 is plus 5 root 2. On the bottom, we're going to get 5 times 5 is 25. Plus root 8 times minus root 8 is minus root 64. And then we've got 5 times minus root 8 and root 8 times 5. So that will give us minus 5 root 8 and then plus 5 root 8. So what we've done by picking this as a minus is we get a plus 5 root 8 and a minus 5 root 8. So those two cancel out with each other. All we've got to do now is simplify these down and get it into this form. So the 15, can't do anything with yet. Root 16 we can, that is just 4. This part here, the root 8 we can simplify. So the 3 we'll leave for a second. Root 8 we can write as root of 4 times 2. And the root of 4 is 2. So this goes to 2 root 2. And we've got plus 5 root 2 as above there. And then the bottom we can simplify. So 25 is going to stay. Root 64 is 8 though. So that's from these bits here. Simplifying this down now. So 15 take away 4 is 11. We've got minus 6 root 2 here, plus root 2 is going to go to minus root 2. So that's what we wanted up there. 25 minus 8 is 17 as required. Question number 22, we are looking at graph transformations. So for part A, we're looking at the transformation from f of x here onto graph A. So we can see that as a reflection in the y-axis. So that is going to be y equals f of minus x, just one of the transformations that we need to learn. Part B, different graph. So we've got g of x here is this wave, and then graph B, we can see that that is a translation. The whole graph has been shifted up by 1. So again, thinking about our graph transformations, we've got g of x, and that is a translation up by 1, so that is plus 1 on the end. Final part of this question is looking at y equals cos x. So we've got our cos graph here, and we're trying to work out the coordinates of this point. So again, one of the points that we should know, But if we break this up into what we've got, we know that that is 90, 180, 270, and 360. So we can see that the x value for C is 180, and then the y value is going to be -1 because our curve, our wave, is bound between 1 and -1. Question 23, we are looking at a histogram. So along the bottom we have our age, and then up the side we have the frequency density. We don't have the scale here yet, so we're going to have to work that out to help us solve this problem. What we are told is that 20 members are aged between 25 and 30. So that is this tall group here. That has a frequency of 20. Now in a histogram, we know that the area represents the frequency. So the area of this middle toolbar is 20. And we can work out the frequency density using the formula that we got. So we know that the frequency equals the frequency density times by the class width, because that is the area of these bars. So the frequency density, rearranging that formula, is going to be the frequency divided by the class width. So the frequency density for the 25 to 30 group is going to be 20 divided by 5 equals 4. So up here on our scale, we can put that as 4, and then we can fill in the other values on the scale, like so. Next, we can see we are trying to find the probability that a member is chosen randomly, that they are going to be 30 years or older. So that is this group and this group here. So we need to work out each of these frequencies, each of these as well, so that we can do these two out of the total frequency to get the probability. So to work out each of the frequencies, we're going to do the class width times by the frequency density. So we can label these separately so that we can keep our working nice and clear. So the frequency of A is going to be 0.7 for the frequency density times by the class width of 10, which equals 7. B is going to be, we've got 15 for the class width and 2 for the frequency density. 2 times 15 is 30. C, we have already worked out, is 20. For D, frequency density here is 2.6, and the class width again is 10. No, it's not, it's 20. So 2.6 times 20 is 52. And then for E, we've got a class width of 30 and a frequency density of 0.3. 0.3 times by 10 would be 3, times that by 3 would give us 9 for that one. So the total frequency is all of these added up. Let's just check we're not told that. We're not. So adding these up, we get 37, 57, 109, 118. And then the probability of getting someone who is more than 30 is going to be these two. So that is going to be 61 out of 118. Final question, question 24, is to do with some probability. Here we're taking a random counter from bag A, placing it in bag B, then taking one from bag B, putting it into bag C. We want to work out the probability that there are more black counters than white counters in bag C. As it stands, we've got 5 and 5, so what we're actually interested in is when we place in a black counter into bag C. That's going to give us the higher probability here. What we need to consider is how we can get that extra black counter into this bag. So we need to look what happens when we take one out of A, and then what happens when we take one out of B as well. So for bag A, let's do this as a tree diagram. We can either take out a black one or a white one. The probability that we take out a black one is the 6 there out of the 10 we've got in total. Probability we take a white one is the 4 out of the 10. So once we've taken out a black one, we're going to put that into bag B. So what that means is instead of having 7 black ones in bag B, we've now got 8 black ones in bag B. So the probability that we take out a black one from here isn't going to be 7, it's going to be 8. And there's not 10 in this bag anymore, there's now 11. So it's 8 out of 11, 3 out of 11 for the white. If we took out a white one to start with, then we would put that white one into bag B, which would mean that we have 4 white ones out of the 11 there now, but still 7 black ones. So this is our bag B. We then take these, so black or white, and we put those into bag C. What we're interested in is when we put in a black one, because this is when we've got more black ones than white ones in bag C. So what we need to work out is these two probabilities. The way we work those out is by multiplying along the branches and then adding together the values we get at the end. So for that top one, it's going to be 6/10 times by 8/11. And we're going to add that to this second branch at the bottom. So that is 4/10 times by 7/11. So working this through, we can multiply the tops of the fractions. So 6 times 8 is 48. 10 times 11 is 110. And then this side we're going to get 28 out of 110. Then adding these together, that is going to give us 76 over 110. We can simplify that down as well to get 38 over 55. Either answer is fine though for our probability. The end.